Hello, and welcome back to Learning with Lee. In today's episode, we are going to discuss what are known as functions. However, before I get into what functions are, I'm going to discuss the problem that functions are designed to solve. And for that, we're going to go back to our earlier example of using a while loop to solve for a square root of some value. And what the problem is that suppose I had a second value. And for simplicity's sake, let's just call it value 2. And I wanted to know what its square root was. Using the current way we have this set up, I'd have to basically copy all of this, put it down here, and then update everything as opposed to using value to use value 2 instead. And I just delete these as I reuse the same variables, but still, I would have to end up updating everything and do this, and then I would have to use this while loop everywhere I wanted to find the square root of some number. As you can imagine, there are quite a few problems that arise from this. Not only would having to copy and paste this everywhere I want to do a square root become tremendously ugly and hard to read for me as a developer, it would make my file sizes larger, it would make the memory footprint larger because your compiler won't necessarily know to compile this the same as it does this up here, even though they're effectively the same portion of code and do the same thing. So the solution to that is what is known as functions. And what functions allow you to do is that rather than me having to copy and paste this down here, what I can do is go, okay, I am going to create a function, and the way in which you do that is you first define what you want your function to do. In this case here, I'm just going to call it square root. So there's its name. Then, the important thing is that similar to the main function, if you remember me going over this, I have to define its type. In this case here, this is what it returns. Down here you can see that for this we're returning 0 since main returns an int. In this case here, since we're operating on doubles for our square root, we want to return a double. And what we then want it to do is we want it to take in some number of arguments, which is what comes inside of these parentheses. And what we end up putting in there just happens to be the value that we want to find the square root of. So we're just going to say double value. Then there is another optional thing that we can do here, so that we can allow whoever's calling square root to determine the threshold they want. So what we can do is we can go, okay, rather than having this here, let's put this up in here, and by having threshold equals 0.5 here, what we're doing is effectively defining a default value for that argument. So in this case here, value is something that the user or consumer of this function must supply. So whoever ends up calling this function has to provide a value for value. However, because we give them this default, they don't have to decide on a threshold if they decide our default one is acceptable or if they don't care what the threshold is. So that's the value of providing defaults. And if I want to, I could even do value equals 0.0, and then the caller won't have to provide anything that would be fairly meaningless because they just would get 0 back. So that is how we end up declaring our function to specify that we're going to be using it later on. Now currently this doesn't have what's known as a definition. And the difference is that I can declare double value like this, and I can assign some value to it later on. And this would be your declaration of that variable, saying that I want to use value throughout this function. However, it's not defined until you assign something to it, and it's a similar thing for functions just as it is for variables. So what you do for functions now is you basically just copy this line up here. Let's head on down below our main function, put it down here, and then, similar to a while loop or for loop or an if statement, we use braces to represent some compound statement here. And we get rid of the semicolon that we had after it on the declaration. So, then in here, all that we have to do is basically copy what we're doing right now with our while loop, as well as we can copy in the square root and the search delta that we use, so as that we do not actually have to have the caller define these every single place that it's using them. We can just go, move these from here, down into here, and what we now have is something that is reusable throughout our main method, as well as, depending on how we set it up in the future, possibly through other functions that we end up having and through other locations in our code. However, there is still a problem with our function, and that is that right now, our function, though it finds the square root and stores that square root in, right now, square root of the variable, it never actually allows whatever calls that function to see what that is. If you can see up here, we have int main, and eventually what it does is return 0, which lets whatever ends up calling main know that the output of that function was 0. So this int that it's referring to here, what it returns, ends up being 0. So down here, what we need to do is we need to include this return statement. And the important thing about a return statement is that as soon as you call a return statement within a function, that function ends. So if I put my return statement up at the very top, and just say return 0 for now, it's going to end up not executing any of the rest of this code and effectively never finding the square root. So what we need to do with it in this case is we need to put it down at the bottom here. And in this case here, what we're looking to return is what we have named square root. What we then have is we have a function that pretty much works. There is a minor problem in that our variable name here of square root has the same name as our function up here. And while this one happens to be within the scope here, and it's overriding the earlier declaration of it, it's a matter of, this would be very confusing to read, because while you can predict that this square root throughout here is a reference to this double, it could also be a reference to the function up here. So just for cleanliness sake, we need to rename this. So I'm just going to name it our guess, since it's our guess as to what the square root is. So as you can see here right now, it's not giving us any errors, because right now it thinks that, yep, as you can see, it's relating it to the function, which is why that is a problem. So we're just going to do this, place all of these, go, that happens to be decent. And really that's all you need to do for updating your square root function. Now up here, how do you call the square root function? Well, all you do is you go square root, input your value. In this case here, we're just going to use value. And we're just going to leave the threshold alone. So we're not going to know what the final delta is here. If I wanted to change it up, I could allow us to get the final delta out. However, for now, this is good enough. And what we really care about now is here's the thing. I have this, but I need to store the double that comes out of square root in something. So I can go double, and we'll just call it result, equals that. And since down here this is trying to currently output this function, we need to rename that to result. There is one problem that I nearly forgot about, and that's that I'm declaring this parameter here for threshold twice in terms of giving it a default value. And the reason that something like C++ doesn't allow you to give this multiple default values is that, for example, and we're going to get into how you can have these in multiple files in the future, but what if I had this one here at 0.5 for the default and this one here at 0.05? Which default should it use? And that can be a major issue, and the way in which it ends up being solved is just to make certain that that cannot occur. So what you have to do is you have to remove that one there so that you only have your default defined up where you declare your function. So then if I build it and I run it, as you can see, it ends up working. And now what I can do is I can just go, okay, let's copy these two lines rather than having to copy previously this entire while loop, the comments, the preparatory assignments up here. Now I just have to do these, go value 2, I can reuse the variable result, do this, build it, run it, and you can see here I've got that final guess and that final guess, and it's even cleaner if I just comment out that line, so we just end up with our two results here and here. So that's the major advantage to using functions, is that it allows you to be much more compact on code in terms of things that you're going to be reusing. So there still are a few nuances I haven't covered with functions. And one of those is that what if I say within this function decided to go value plus equals 50? Because this is a valid thing that I can actually do within mine. I can do this, and it will actually make those modifications, and it will mess things up appropriately so that we now end up with finding the square root of 150 rather than that, or 1,050 down here. Now the problem is that the question then is that does that actually modify this value out here? So just for clarity's sake, let's comment out this line again. Then up here, let's go with something like saying value is, and then giving it the value, so we can see what the value is, and then what we're guessing at. So what you can see here is our value still happens to be 100. I didn't leave a space between N and the F, but that sort of is another issue. But for this, it's a matter of even though we added 50 in here, it did not affect this value out here. And that is because functions do what is known as pass by value. You can do what's also known as pass by reference. However, the major thing is that for primitive data types, what it will do is it will go, I'm going to copy this memory, whatever's within there, and I will use that for the value that exists within this function. So this value here is completely independent of this one here. However, the way in which you end up, say, if I wanted to modify this original value up here, is I put an ampersand in both the declaration and definition here. So if I do this here and this down here, it tells me that I want to modify whatever gets passed in there. So if I then build this and run it, you can see right here, now it's 150 rather than 100. And that's the difference between passing by reference and passing by value. And we'll get into some of the larger implications of that in the future. But for now, it's important to know that when you do pass something in, unless you expressly tell it to, it isn't going to change the value of that primitive data type. There are a couple of additional tricky nuances that exist within functions, but those I'm going to cover in the next episode, as each of those take a fair amount of time to properly discuss and introduce. I would recommend working on a few different functions on your own. Consider seeing, in case, let's say that I give you some array of numbers, checking if a specific number is in there. So the general declaration for that would be, we're just going to say, since it's a bool, we'll just call it has value. And for simplicity's sake, we'll just say that this is an array of ints. Within that array of ints, we need to know how large that is, so let's have an unsigned int for its size. And then we end up having, beyond that, our int value that we are looking to find. So I would recommend for your homework assignment to sort of work on figuring out how to do this in order to check that array to see if it has value in it, as well as then just see what you can do to mess around with different ones. Try a few different things, such as I had mentioned before, seeing if you can come up with something to find the lowest common denominator or least common multiple for two different values, something like that. Or see if you can figure out how to translate a number from like this, where it's in double or integer form, so as that then it happens to be an array of characters. Or so as that you can output those characters as though they were characters. It's a bit easier in this because you could just say, well, I'm just going to see out value. But in case you really want to get into how to translate that into a character array, then that would be a bit of a more ambitious thing that you can try working on. So thank you very much for watching. I hope you have a wonderful day.